Welcome to Infinite Limits. So the idea here, we have seen cases where a function does not appear to be approaching a specific number and instead it grows off to infinity. Right? So we have seen functions where instead of approaching a single value, the function heads essentially to infinity. Or negative infinity. And so we essentially allow ourselves to have a positive infinity or negative infinity as our limit. And the limit, we say the limit is positive infinity if both sides go to positive infinity, and negative infinity if both sides go to negative infinity. So we say the limit exists if the sides agree. So let's go ahead and take the function f of x equals 1 over x. So in terms of the graph, when x is positive, 1 over x will be positive. When x is negative, 1 over x will be negative. And the function itself heads off to positive infinity when x is close to 0, and then heads towards 0 when x gets large, and starts close to 0 and then heads towards negative infinity if we plot the values. If we divide by large numbers, we wind up with a small answer. And if we divide by small numbers, we wind up with a large answer. So if we look at the limit as x approaches 0 from the left side, coming from the left side, if we trace our graph, it looks like we are going on forever heading towards negative infinity. So from the left side, we would say that we're heading to negative infinity. So coming from the left. And now let's do going from the right. So coming from the right, as we work our way towards 0, it looks like we are heading towards positive infinity. So the limit as x approaches 0 of f of x, the two sides don't agree. So these don't match. And so we would say that this limit does not exist. Again, shorthand notation, you might write this as DNE for does not exist. Now let's take a look at the function g of x equals x plus 2 over x minus 2 squared. If we consider the graph of this, when x is negative 2, we're 0. Before that, the graph would be negative, and then we switch to positive. oops, sorry. And then at positive 2, our graph is undefined. So let's just make a break at positive 2. We'd be dividing by 0. So we start off negative. We go positive. And then as we get closer and closer to 2, that denominator is closer and closer to 0. So we're going off to infinity. And then from the right side of 2, we're still going to be positive. And so x minus 2 squared is always positive. Oops. And then our numerator is negative before 2. And then positive, sorry, before negative 2, and then positive after. So on the, if we're to the right of negative 2, we will always be positive, and that'll keep both of our infinite sides going off to positive infinity. So as we come from the left, we're going off to positive infinity. And if we come from the right, we are also going to positive infinity. So these match. So we're going to say that the limit exists in this case if we're including infinite limits and is positive infinity. So again, we're not technically approaching a specific number. Infinity itself is not a number, but we can at least sort of use this definition to say, well, both of the sides are approaching or heading off in the same direction and shooting off towards infinity.